Thank you.
Great, thanks very much, Tim. Morning, everyone. Thanks very much for allowing us to join you. I'm accompanied by my colleague Richard Simon, who's technical director of Solarsense. So I'm sure you'll have some fiendish questions at the end of this presentation to test his knowledge. Without further ado, I will attempt to start my presentation and share it with you. Okay, so is that successful?
Yes.
Can everybody see that? Yeah, excellent.
That looks good.
Okay.
Yep.
All right. Well, thanks very much. As Tim said earlier, we are Solarsense. We're a renewable energy company who are based near Bristol. We've been in the market for 25 years. So we have some experience of solar, over the history of solar. Obviously, what we're going to be looking at today is more about the future path that solar and energy markets overall will be taking. Okay. Okay, so as we're all aware, and as most councils have declared, we have a climate emergency. So unless we change what we're doing, we will cause devastating consequences. So we have to stop our emissions of greenhouse gases. It's as simple as that, as Greta Thunberg tells us. So to stop emissions, we have to address how we produce them. Sorry, I'm just trying to, I'm aware that I keep looking down to read my notes because the gallery is covering up my notes on the screen. Let's see if I can hide that. There we go. That's better. Right. So to stop our emissions, we have to address how we are producing them. And as you can see, this is from some information which was produced by Bath and North East Somerset County Council. 90% of emissions are coming from buildings and transport. So to stop the damage we're doing to our planet, we have to adopt technologies to heat and light our homes, offices and factories, and power our cars and vans and lorries without using hydrocarbon fuels. Time is running out, so we must do it at scale and at speed. There is increasing weight being put behind the ideas of people like Tony Seba that the 2020s will see a big transformation in humanity with the convergence of technologies in IT, energy and transportation. With prices dropping, using less resources and less waste, renewable energy production will be local and distributed via the Internet of Things. Energy will not be produced by extracting minerals from the planet and then refining it, shipping it across the globe to populations that use it, but instead energy will be generated locally by the communities and to the communities using smart technology. It will power our homes, our vehicles, and indeed our world. As I think many of you probably know, this has already started to happen. Okay, so I've got another video here to play. This is a promo for a development in South Australia.
Mm-hmm.
Okay. So that, like I say, is happening in South Australia. But this sort of thing isn't only happening on the other side of the world. Solarsense has recently been involved in discussions about a very interesting project, which some of you might be aware of, in West Sussex. This project, which is a smart local energy system, plans to have solar on 250 domestic residence homes and about 100 commercial properties, and use solar batteries and smart software to manage smart charging of batteries and electric vehicles. The software uses artificial intelligence to learn and optimize daily charging, leveraging low carbon resources and time of use electricity tariffs. Now, obviously, these projects are all well and good, but these are projects on a large scale. But you're probably wondering how we can use smart solar systems to help individual houses or buildings at a grassroots level. The answer is that it is possible to use smart systems on local grassroots level in some fundamental ways. This is a slide comparing a traditional house with a passive house. Even with retrofit on traditional houses, using smart solar systems can move away from the dependence on hydrocarbon fuels and use solar generation to power our buildings and vehicles. One of the key ways this is moving from an energy, this is one of the key ways that this will move from an energy evolution to a revolution. And the thing which is really important about this is the cost of solar becoming more competitive than traditional energy sources. These slides here show how over on the left-hand side, you can see how the cost of solar panels has fallen, and on the right-hand side, you can see how the power of solar panels has increased over the last 20 years or so. And there's been a fundamental shift. Prices have dropped by four-fifths, and power output has more than doubled for basic panels. 370 watt panels are now very common and very competitively priced, but there are also 400 watt panels available, readily available on the market, but they're slightly more expensive. But also 500 watt panels are also available and have been launched, although they're not generally available currently. Now, cost-effective generation is one thing, and like I say, it does democratize the availability of solar. But as I'm sure all of you are aware, one of the challenges about renewables is that renewables generate energy when conditions are right for them, but not necessarily when we want to use the energy. So this is why we need things to get smart. So we can optimize usage when the power is being generated, and then look at how to store any surplus. A simple way to store and optimize generation is by storing it in a hot water cylinder. It's relatively inexpensive, and it does have a great impact on the usage of the solar. And this is by diverting excess solar energy via smart software into a hot water cylinder. Modern insulated hot water cylinders can store energy for up to 24 hours. So like I say, it does make a big difference. But the real smart stuff happens with the inverter. Inverters used to just be a way of converting direct current, which is obviously generated by your solar panels, to the alternating current that's used in buildings. But now smart inverters can give you information on the performance of each panel and control where the energy flows to. Whether it flows to your building or to your battery, or now increasingly from your electric vehicle. So I'm going to show another quick video here about how this works. As you can see on the bottom of this inverter, there is an addition, which is an EV charging point. There we go. I ought to point out that I'm sure it's not Zoom. I'm sure it's my inability to use Zoom, but I can't get the audio from these videos playing to you. But as you can see, most of them have subtitles, so it's not a big problem. So yeah, the other thing I want to point out is that these systems that we're looking at, like the Solar Edge EV charging point with the inverter, are commercially available on the market at the moment. Solarsense are supplying these to just normal day-to-day householders. So yeah, I mean, this is, like I say, this is real technology that is available currently. Now, whilst we are looking at electric vehicles, I'd like to just broaden the discussion, or broaden your thinking maybe, into car parks and the availability of space in municipal car parks. So I have another video here which illustrates these opportunities.
Simon, you might have the volume turned off on the video play.
Bottom left-hand corner.
There you go. Yeah, no, thanks for that advice. Tim and I did have a little test earlier on.
There it is now.
Yeah, but it unfortunately it only plays into my headphones. It doesn't into my earpiece.
Right.
It doesn't play over Zoom for some reason. Anyway, like I said, I'm sure it is. I'm sure it's not Zoom's fault. I'm sure it's my fault. But anyway, thanks for
Okay.
that suggestion. Okay, so like I say, there is a potentially valuable untapped resource in people's car parks. Oh, hang on, sorry, I've skipped a slide. There we go. Now, to show how this can work in practice, this is a car park, which is a municipal car park, which is deploying solar carports with battery storage. And this is the design we've made for this project. As you can see on the left-hand side of your screen, there's a 500 space car park, and on the right, that is the solar car ports that we would deploy onto that space. This would use 2,100, over 2,100 370-watt panels, turning this municipal car park into a generator of 800 megawatt hours of electricity. There's also smart battery storage. There's 2 megawatts of smart battery storage, and EV charging points as well. So it's a good example of making the best use of space available with collateral benefits. Just to go into a bit more detail here. So the storage unit is containerized. It's a containerized storage system capable of accepting DC tied solar direct to the battery via a string of optimizers. The energy management system will integrate the solar system with both the building, which, as you can see on the top of the slide, which has existing solar, and the electric vehicle charging point load to maximize the benefits of solar and battery generation. Okay, so even on a smaller scale, smart systems can make a real difference. A recent report by Loughborough University, which was sponsored by the Solar Trade Association, concluded that homes with solar PV battery storage and intelligent controls can reduce peak time consumption by 87% annually. So what we're saying here is if you use battery storage and use your use what you had stored during the peak time, you can reduce peak time consumption dramatically, which obviously is incredibly useful for the grid, apart from anything else. Also, more importantly, this this study found that even with, so with the use of smart controls, even where houses also had electric vehicle charging points and air source heat pumps, which obviously add to the electricity load, there were similar results with battery storage. So like I say, smart systems can have a dramatic effect on consumption in homes and what gets used and when it gets used, or when it is pulled from the national grid. Okay, so obviously some of these things that we've been looking at are things that are currently here. Some of the things we've been looking at are really somewhat in the future, particularly the last slide where everybody basically would have a home battery. I think that the social, environmental and economic benefits of smart solar systems are clear. But currently the supply for battery storage is lagging behind the demand. But that will change in the next couple of years. This photo is Tesla's Berlin Gigafactory, and this is currently under construction and should be in production in 2022. Now, a gigafactory is called that because it has the capacity to produce the minimum of 1 gigawatt of battery storage capacity in 1 year. I believe the Tesla one they're building has a 4 gigawatt capacity. And as I think many of you might be aware, Elon Musk has also taken a visit to Somerset recently to look at a second European gigafactory, potentially based near Bridgewater. But Tesla aren't the only people who are doing this. By 2023, there will be at least 7 European gigafactory factories scheduled to be in operation, with a capacity to produce 80 gigawatt hours of battery storage per year. So this will readdress the balance between supply and demand, and prices are already falling in anticipation of new production coming on stream. Tesla, just at the beginning of this month, reduced the prices of their Powerwall battery. So, like I say, solar panels is a developed and now very affordable market. Batteries also are going to become affordable over the next few years. And also, there's going to be greater availability of smart controls and trading platforms. And this is important because this allows for battery storage, aggregation, and grid sharing. Now, this is also an advanced development from various suppliers, which include disruptors like Octopus and Moixa and Tesla, but also traditional suppliers like EDF Renewables, and Scottish and Southern Electricity as well, are also developing virtual power plants. But also you've got oil and gas majors as well, like Shell and BP, who are also buying up electricity retailers and moving into this space as well. So I believe it is very likely in the next 10 years the energy landscape could be completely revolutionized, excuse me, completely revolutionized, and renewable energy will be produced locally, distributed locally, for and by local communities. Okay, so I hope you've found this presentation interesting, and now we can take questions on the presentation or any other renewable energy topics that you might have.
If anybody'd like to raise a question, please raise their hand and I'll invite them to speak. So first of all, I think Dando's waving his hand.
That's right. When you say that panels now can be 370 or 500 watt, is that in the same size as now exists?
Yeah, that's a good question. Yes, the size, some of the bigger panels, the size has increased slightly, but not dramatically. So, for instance, a 370 watt panel is 1.7 meters long, whereas I think a 320 watt panel is 1.6 meters long. So it's not dramatically bigger. The 500 watt panel is slightly bigger, so that probably would be more for commercial rooftops than domestic rooftops.
How does that work out?
A second question, please.
Dando again. Just
you mentioned storage, water storage, hot water storage, but surely that is not sufficient for most things. So I divert myself to hot water during the day, and just for half an hour, and that is enough for me for my personal use every day. I cannot see that having huge hot water supplies would be of any advantage.
Right, okay, I think possibly I didn't make myself clear in the presentation. I was talking about, as you say, diverting water from panels on a roof in a domestic situation for the use of that household. And as you rightly say, it doesn't take a lot of solar diversion to heat your water, which, like I say, is obviously you are effectively storing the solar energy in your water until you want to use it, but it's optimizing also the use of that solar power.
Yeah, just to add to that, Simon, can you hear me?
I can.
Yeah, yeah.
Oh, yeah. Just to add to that, I mean, I think that example that Simon showed is it's just another form of storage. If you've got large hot water demand, then it makes even more sense. If you've got process heating, even low-grade temperature hot water, it can be used for that. I think, the principle is it's just another form of storage, similar to battery storage to store the electricity. You can store it as thermal energy as well. And again, it's up to you or us or anybody to look at the figures and look at demand and supply and what you're using at what particular time, which is, as Simon was saying, is the way forward, really, the smart load management and how to optimize use of renewables.
Thank you, Richard. I should have introduced Richard at the start, actually. Richard is actually the technical director of Solarsense, so you should know what he's talking about there. Now, is there anybody else with a question? Please raise their hand if there are. Can't see anybody raising their hand. Oh, Pam.
Pam, yeah.
Go ahead.
It's all right. It's okay. As we're just about to update our electric car to one with a bigger battery, we'd be really interested to know more details about the Solar Edge EV charging solar inverter, including whether it includes a charging point, sort of high power charging point, and roughly how much they cost.
Yeah, that's a good question, Pam. Obviously, I'm sure you appreciate the inverter would have to be linked to solar panels. So you have existing solar generation, do you, or are you looking to add that? Yeah, right. Okay. Excuse me. So yeah, I mean the the charging point is at the bottom of the inverter. So the inverter also would have to be located either in your garage or on the outside of your garage or on the outside of your home, but somewhere obviously within 7.5 meters of where you park your car, because the charging lead comes out the bottom of the inverter and would get to your car. As far as costs are concerned, if you were buying an inverter because you're installing a system, the additional cost for the EV charging part of it is about £400. Whereas if you were having an EV charging point, a dedicated EV charging point put in your house, it would probably be about £500 or £600.
Okay, thank you.
Steve.
I am going to ask a very, very political, possibly NPC question. If we do fall out with the Chinese big time, which things are, they're a bit in the offing at the moment, what would be the effect on the solar panel production? Because I would imagine we buy an awful lot of solar parts for the panels from the Chinese. How much do you feel we can do this back as a country?
Yeah, I think that's an interesting question, Steve. I mean, energy has always been a geopolitical topic and a geopolitical industry, and I would suggest that part of particularly the US's concern about the rise of China and Chinese influence is because China is leading the way in renewables and solar, which threatens the US's geopolitical hold on the main source of energy in the world, which is oil and gas. But moving away from my own personal theories, I think that because the cost of solar panels is falling, the transportation of a low value commodity from one side of the world to another side of the world very soon won't make sense. So we will have to have local production of solar panels closer to the markets that they're going to be supplying. You're right, currently the majority of solar panel manufacturers are based in China, whether they are manufacturing for a Chinese entity or a Korean or Japanese or even German entity. They are manufacturing in China. But there are factories outside China. There are factories in the US, SunPower manufacturer outside China, REC, which is a Norwegian manufacturer in Singapore. But like I say, increasingly, there has to be manufacturing more local to the markets because, like I say, solar panels are quickly becoming a commodity and a commodity with lower and lower value. So it makes no sense transporting them so far. But I suppose
okay, yeah.
A few years ago, I went to to France, to Lyon, where Total Fina Elf were manufacturing panels, and at the time, the crystals were being grown in Germany, being sliced in Scandinavia, and then they were under an EU-funded operation going down to South Africa to be put into the panel, and then the panels finally assembled back at the Total Fina factory in Lyon and then distributed. So the possibility of making them in Europe is there. We obviously have got to go back to what we were doing years ago.
Yeah, if I can add to that, this is a bit of a hobby horse of mine, because when the COVID virus struck first in Wuhan and the Chinese production plants shut down, it really did affect our supplies. We had to grab whatever was going and secure some supplies. It held up containers in Rotterdam because they were being disinfected, all the rest of it. So it made me realize how vulnerable our industry is to being reliant on one country producing the cheapest panels. So just to say that we do make some in the UK. There's a company in Durham called WEEMG that basically a glass manufacturer. That's where their history is, and they make more bespoke type solar cells and panels and assemble them there. Going back 15 years, Solarsense itself, I visited the Sharp production plant in Wrexham, and we used to buy and fit Sharp solar panels, and it was almost like a cottage industry. You know, there were a lot of, it was fairly manual labor, people sort of trimming the panels by hand and so on, but, it could have done with a bit of automation. But Sharp decided they could get it done cheaper elsewhere, and they shut the plant, which was previously a video recorder plant. So you can easily transition technologies to move to whatever you want. It's a political decision, really. So basically, I think we ought to encourage homegrown technology, solar stuff, and make us more resilient and less vulnerable to these, whatever the next crisis is going to be. I don't know what it is, but there will be one around the corner.
Yeah, but I mean, as you say, Richard, in those days, it was cheaper to get it done manufactured in China. But like I say, as transport costs become a bigger and bigger proportion of the panel, that will no longer be the case. When panels are, when the panels are producing for a few pence per watt, the cost of the panel, then it'll be madness importing it from China, and it will be more cost effective to manufacture in Europe.
Yeah.
The embodied energy that goes into panels, including transport and so on, can you just throw a little more information about that kind of figure so that we can gauge that against what the panel will produce over its lifetime?
Can I ask a basic question, please, with regard to standards relating to these component parts?
Hold on a moment, Roger. If you just allow one question at a time, please. I'd like my question first answered, then you can have your question. Otherwise, it's so confusing.
Okay. Is that about the embodied energy?
Yes.
Okay. I mean, surprisingly, it is very cheap to sail vast tonnages of anything around the world. Mm-hmm. But I don't know the figure, but it is that it is very cheap. So the embodied energy of sending a few megawatts of panels it's not going to be prohibitive. It is a factor. I don't know the figure off the top of my head. It depends how full the ship is of X number of panels. But I know generally, the REC's panels made in Norway, because they use a lot of hydro, I think the embodied energy, is paid for itself within a year. So that's the sort of scale. Maybe if you're shipping it from China, it might be a year and a half, something like that, in terms of embodied energy. But Simon's right. It is a factor. It's generally the idea of hauling stuff halfway around the globe. It's madness, really.
Okay, that's fine. Roger, I know you've got a question. Perhaps you'd like to ask it now.
Thank you. Well, apologies for interrupting. I really would like to know what standards exist, what accreditation standards exist regarding component parts or the general assembly? How do I know whether I'm buying a bag of rusty nails from China or something which is more of a, shall we say, Lexus engineering standard?
Yeah, I can answer that one. So there's this thing called the MCS, Micro Generation Certification Scheme, and we are only allowed to supply components that have been through rigorous quality control procedure and are then registered on the database. And when every installation, we have to obviously produce O&M manuals and handover packs, and within that is usually a MCS an MCS certificate, installation certificate, and on that, as part of that creation of the certificate, you have to state which product you've used. So the products can only get onto that database if they've been through this rigorous quality control. It does involve people, say, from the UK going out to factories in China and seeing what their ISO 9001 is or whatever, and it costs the manufacturers several £1,000s to do it. So yeah, you can't just go and fit any old bit of kit from anywhere.
Is there a European norm?
A European
standard, European norm standard, EN standard.
You have to have to sell anything in the EU. You have to have you have to meet European trading standards.
Yeah, there's a trading standard, but then there's the component standards as well.
Yeah. But these obviously are electrical components, so you have to meet EU safety standards and EU testing standards.
So there is a standard I could reference, is there, with regard to basic solar energy and systems?
Yes, I'm sure there is. Is there not, Richard?
Yeah, I'd have to refer to the documentation. I mean, all the, say, for example, the inverters, they are all type tested, and they are given an approved certification number. So you can't really use equipment like that unless it's been through those standards and
so,
approval.
In broad brush terms, if one bought, shall we say, a German solar panel, as an example, the chances are, whether they sourced it from China or not, it would conform with DIN standards and as such European standards, and there would be a measure of assurance there in terms of the quality and reliability and longevity of that component.
Yeah, correct. I mean, there's the not just the technical quality, but the financial bankability of the company. We tend to go for tier 1 panels, which is a measure of the financial stability of the company as well. So there's a lot of queries about warranties and whether the warranties are worth the paper they're written on. So that's why we tend to filter out larger companies. Well, other companies with recognized brand names like LG. We fit a lot of LG panels, but LG also make lots and lots of other consumer goods.
Okay.
Thank you. Phil, you've got a question.
Right. Thank you, Tim. Could I just ask about the environmental implications in the making of the batteries, which are a big part of this smart system? I'm not too hot on how the batteries are made, but is it sustainable, whatever the materials they're made of?
Well,
sorry, Richard, carry on.
Sustainable. I mean, no, I think we'd probably run out of cobalt, which is a crucial part of lithium-ion batteries at some point.
Right.
But
yeah.
I mean, it's all relative in terms of time frame, really, isn't it? I mean, well, look at what's been sustainable over the years. I mean, basically, there was a point where people were saying, look, Africa, there's not enough copper in the world to provide Africa with a telephone network. And what happens? Mobile phones come along.
Yeah.
Yes, so it is sustainable. Yeah, we probably will run out of the raw ingredients of lithium-ion batteries, but you know, by that time, 20, 30 years after Elon Musk has produced billions of gigawatts of them, there will be other technologies that are replacing it. You have to be a bit of a crystal ball gazer to know where that is, but for now, there's you know, I would think there's enough to bring about the sort of transport revolution and the decarbonisation to a point. Well, you know, let's worry about that problem in the future. Really, a bit like, well, fossil fuels are reaching that point where it's not sustainable. So, and what are we doing? Well, we're looking at alternatives now, aren't we?
Okay.
Thank you. Eric's got his hand up there.
I'd just like to say, following on from that, there was a really interesting article in Nature about the sort of challenges and opportunities for recycling lithium-ion batteries. And if you sort of Google Nature lithium-ion battery recycling, you'll find that article. And it makes really fascinating reading. It goes into a lot of detail about the different technologies that are available to recycle batteries. The main thing at the moment is that because everything's dependent on the sort of market forces, there isn't a financial incentive for people to recycle batteries at scale, which is what it would be needed. But as the previous speaker was saying, that, you know, when cobalt becomes more of a pressure, it's likely to mean that people will be building gigafactories to recycle them as well as to manufacture them. But until there is the market pressure to do that, obviously they're not. But it doesn't mean that recycling them is impossible.
No, I think that's a very good point, Eric, and I believe, although I'd need to check this, but I believe that recycling of batteries is one of the key planks of many of the battery manufacturers' business models, because, as you say, the batteries need to be recycled because they can't be destroyed. So I think it is recycling is a very critical part of like I say, the financial calculations that are made by the people who are manufacturing batteries.
That was a good reply, thank you.
Linda, I believe you've got a question.
Yes, it was actually going back to the conversation several tiers back, but it was just to say, when I worked in the industry, we used to buy panels from Canada and Japan, the US, and particularly a really good panel from Germany, and that Germany did lead the world for many years before China came up the ranks. So I think in Europe we've got good quality panels as well.
Thank you.
Yeah, I think they basically a lot of the, sorry, just to follow on Linda's, yeah, a lot of the European manufacturers stopped producing because cheaper supplies were available in China. But I've got a feeling in Dresden, I can't remember the name of the German company, but I've got a feeling they're starting up production again with highly automated, obviously. So, I mean, I think that we're at the point where the pendulum's just starting to swing back, I think.
Yeah, and I think that, I mean, Linda, you make a good point there, and certainly in Germany, there's still a lot of development of smart solar systems, so batteries and inverters, etc. There's still very strong German technology involved in those markets. Like I say, I think with the solar panels now, they are becoming more commoditized because it's relatively, you know, in technology terms, it's relatively old technology now. And so it's fairly simple to just mass produce. And so you do that in a cheap mass production environment.
Right. Anybody else now? Paul, I can just see the top of your head, Paul.
Ah, right. Well, Tim, I wonder if you can let me in a second time, because my screen has gone completely blank, so I can't see anybody, but I've got another machine which is waiting to come in if you'll let me in. But I've also a question with regard to, completely in parallel actually to what I think was the second question, i.e. I have solar cells on the house, I have an electric car, and probably within 12 months, I will have one which will, as it were, exchange energy in and out of the battery. If I, as I would need to do, change the inverter such that it's got this charging point connected to it, and one has the clever system managing what's going on. Did you say that the new inverter would just cost £400?
No, I didn't. No, I said that the additional cost of the electric charging capability of the inverter would cost about £400. So you'll have the cost of the inverter plus £400.
And I can't use the inverter I have at the moment, I assume.
Well, obviously we don't know what inverter you've got, but
But it's 10 years old.
Yes, I think it was unlikely. I think it is. I mean, Rich is better placed to comment on this than I, but I think it is unlikely that they would have anticipated your need to import power from a battery 10 years ago.
So what would the total cost be?
It depends on the size of the inverter and your requirements.
Well, it's the standard domestic 400 kilowatt array.
4 kilowatt.
And it would have the quite a sizable car battery to absorb and as it were, give out the stored energy. In other words, it would provide the capacity necessary, I would believe, anyway, for the system, as it were, to stand with just those two components.
I think you need to be well smart, really, when you're really considering all the what your requirements are, because I mean, there's two schools of thought on this. The car battery is for traction, really. Are you saying that you'll be able to store energy, take energy from the car battery to provide power for the house?
Yeah, I mean, this is one of the concepts going on now, isn't it? That you support the grid when the cost of energy is very high, and put the energy back into the battery, as it were, during the sunshine days, hours. I'm thinking of enclosing the system such that the capacity in the car battery, which will be not a lot short of 100 kilowatt hours, would actually supply the whole of the house. So I stopped buying electricity anymore. Given that at the moment I only use the electric car approximately 2 days a week for about 100 miles round trip.
Yeah, that's what I was saying. You need to evaluate your whole driving profile and your house load consumption, because you need to ensure that there's enough mileage in the battery of the car to get where you want to go. So I'm just saying you need to take an overall view of it, really.
What I have in mind is buying something which has got about 250 miles in terms of capacity, distance on a full charge, and I would be more expecting to do maybe 100 or 200 a week. But anyway, what I'm really interested in is the cost of the system, i.e. I've got the solar cells, I've got the car with its battery, so I've got my battery storage. What is the cost of the clever inverter?
Yeah. Do you have the car now, Paul?
No, I'm anticipating buying it within the next year. I do have one at the moment, but it doesn't have this kind of two-way facility.
Yeah, I mean, this is a fairly new evolution, and you're absolutely right. People are looking at the possibility of using their cars to to generate power to power their homes. And so it is not, it's not something, to be honest, that I have a, I'm aware that there is the capability as yet to export from or import into your house from your car battery. So we'd need to do a bit more research on that.
Yeah, I've been to a couple of seminars on it, and most people say we're 2 or 3 years away from having that system that works. But in terms of cost, I mean, you know, you're probably looking at almost the cost of like a Tesla Powerwall battery of 7 or 8 grand, really, because you've got to have all the you have the inverter and charger that will take power from the car and then provide it to the home. So it's I think it's still in the development stage, and I've not seen anything that's actually on the market to do that. I think Nissan are researching it, but that's about it.
But there is at least one company you can buy your electricity from that provides precisely that service. If you've got a car, you know, electric car, which will take and deliver.
Is that Octopus you're talking about? The Octopus?
Well, it might be. I'd have to research, to be honest.
Okay. I think there is Octopus. Do have a what's now, in fact, it's for Tesla at the moment. It's their Tesla tariff, but that uses a Tesla battery to create peak shaving. So you know, as what you're saying, but it doesn't take it from it doesn't take power from the car. It takes it from the Tesla battery storage.
Right.
Thank you. Eric, again, I can see he's got another question. Perhaps you'd like to.
Well, it was just more following on from that discussion. You know, one of the things, obviously, you've got to remember that whilst using your car battery is great for helping with grid balancing, if you're thinking that you're going to have a system that is essentially free of grid electricity, then you probably need quite a bit more in the way of the actual solar panels. Now, my mental arithmetic, just done quickly whilst I was listening to you, might be totally out, and apologies if I have ended up with an order of magnitude out, but just my quick scribbling suggests that on a 4 kilowatt peak PV array, if you drive your car for about 150 miles, you'll be using more or less the entire output of your PV array, which means that there'll be nothing left to run the house.
Yeah, I think that's right. We're getting to a stage where you know, there's so many more electrical loads coming into play here that you're right. You know, a 4 kilowatt array on say a house or commercial properties or whatever, the limit is roughly 1,000, you know, 1,000 units per kilowatt. So your 4 kilowatt domestic array will produce about 4,000 units. You know, and so you've got your house electrical load. If you start whacking a car charger on, that's really going to demand it. So I think these things need to be done in conjunction with maybe buying in from the grid at cheap rate. That's where the real benefits are. You know, we've had a few customers that said, I want a Tesla Powerwall put in. I might get a car soon, but you know, for now I'm just playing around with the tariffs. So they'll draw in at night and produce and use cheap rate at night and offset the peak rate during daytime. And some of that could be car charging. So yeah, you know, there's lots of the limitation is we need to just think a bit beyond the number of panels you've got on your roof. But obviously, the more the better, you know.
But yeah, I mean, you might actually need to add some panels to your roof pool to make this to make your plan come to fruition.
Well, I have been thinking that. The big problem is that in a couple of months' time, I'm 75, and I'm not quite sure how long I'm going to be living in this house, much as it were, which is a little bit of a difficulty. But that to one side. The reason I was thinking of it as this conversation's gone on is that my house solar cells are almost due west facing, and therefore to have some cells on the other side of the house would certainly balance the income. But the problem I've got is I have a very good return from FITs, but that of course is limited to 4 kilowatts. So it would be, I'm not quite sure how to do that and whether it would be worth doing.
Yeah,
I
well,
noticed
that's a conversation that we could have with you. You're right. You can't mess about with your existing system with the fits you've got on that, but you could add panels. But that's probably something we'd need to talk to you about offline, because I'm sure it's not necessarily of interest to everybody else.
Going back to an earlier point, my cells generate about 3,500 units per year.
Good. Excellent.
Yeah.
Thanks, Paul. I've got a hand. I'm not sure whether it's Pam's or Ken's.
It's mine. If I can make an observation and then a question. The observation is that we have to get away from the impression that we can tap into cheap energy and just live our lifestyles as they are at the moment. We actually massively overconsume. So Paul's made the point that his car spends most of its time sat on its drive doing nothing. Mine does exactly the same. So we're going to have to get a lot smarter about transport options, i.e. a lot less cars on the road. My own MP told me 3 weeks ago, it doesn't matter how many cars there are on the road, which shows the stunning level of ignorance on his behalf. So the quick question to you, Simon or Richard, can you just give me any indication of what's happening with the efficiencies of the panels? In other words, are they able to generate in lower light conditions so that we can get more electricity? Because we had a phenomenal period here of the sunshine in March and April. We had tremendous fit payment. It was about almost £1,000 for that quarter. What I'd like to see, of course, is to see the panels actually producing more in lower light levels. So in winter, we get a better output from them as well. Is there anything like that on the horizon?
Yeah, I mean, generally panels seem to be leveling out at around 19, 20, 21% efficiency. The monocrystalline do work better in direct sunshine conditions. There's this other technology called thin film, which is where the semiconductors sprayed onto the surface, and they do operate better in lower light levels. But and we fitted a few, but you need about 50% bigger area in order to get the same kilowatt, the power out. So no, I mean, in answer to the question, there's most of the panels are still doing what they did for the past 20 years, really, but with marginal increases in efficiency. So not unless you go for thin film, you're still kind of stuck. But anyway, who knows what's around the corner? Lots of things in R&D labs, but take a long time to come to the market, we found.
Thank you. Now, can I see any other hands going up?
Eric, did you have a question? Yeah.
Yes.
Well, my question was really that I think it's possible that quite a few of us might be interested in the thing about extending existing arrays under the restrictions imposed by FITs. And my sort of feeling, that I'd like confirmation whether this is true, that with the introduction of more microinverters, it would be perfectly possible and legal to add an additional array that didn't feed through your existing export meter and therefore didn't contravene the rules of FIT. Is that correct?
Yeah, you have to stay away from the FIT meter if you add panels. And there's nothing stopping you adding panels apart from checking it out with the DNO, distribution network operator, because they've, I mean, basically you can fit up to 16 amps a phase without seeking permission from the DNO. So if you go over that and you put on another 2, 3, 4 kilowatts, you would have to check it out with them first. But as far as the FIT goes, that wouldn't affect the FIT because the additional panels wouldn't go through your FIT meter. It'd be a separate, it'd just be providing your meeting more of your house demands or your car, whatever.
Thank you. Now, is anybody else? Yes, Darren.
Hello. Yes, it was a question really around going back to batteries, where you were talking about the the new gigafactories coming on. Whereabouts do you sort of see the price point being for either electricity or the price of the batteries, where this is going to really take off? Because obviously we've seen the tipping point happen now for solar generation. What is the sort of, is it 10 pence a kilowatt I need to be saving when I'm storing it? What is the sort of, is there any guide you can give us on the number that make it economical?
Yeah, I guess so. At the minute, the Tesla Powerwall is the cheapest per kilowatt hour of capacity of storage. Is about £600 a kilowatt hour. Now, obviously, okay, if Elon's going to be building a gigafactory in Bridgewater, then it's probably likely to come down to half that. But fitting a Powerwall and utilizing smart tariff purchases, I mean, that's sort of cost effective now, but obviously it's going to open up the markets if we drop from £600 a kilowatt hour to £300 a kilowatt hour. That's what I'd like to see anyway. In a similar way that the solar panels have come down from price. Well, I can remember 20 years buying them for £3 a watt, and now some are down to like 20 pence a watt. So it have been incredible drops in prices, and the same will happen with batteries, I'm sure.
Yeah, and just sort of it makes you wonder what's going to happen to the network charging as we move more to sort of self-generation, doesn't it? Because you sort of wonder whether on the one side we're going to be making a tipping point, but as we start to self-generate, the revenue's got to be collected for all those distribution cables and things as well, even if we're local. And you wonder, it's going to be quite an interesting journey the next sort of 20 years as all that plays out as to
oh yeah, absolutely. I mean, I think maybe we just need to look at the network as more of a, dare I say it, a sort of public infrastructure service. Very much at the minute it's kind of the DNOs are always seen as rather an obstacle to get over. But really, I suppose we should be upgrading our networks to be able to take all the decarbonised renewable generation, really. But then that would require billions of pounds of investment, well, which we seem to have available at the minute anyway. So why not spend it on the grid?
Yes, absolutely. Pam?
Yes, just on that subject, the Watton Village estate, which is going to be built in Bridport, or maybe is already built, is doing a deal with Octopus so that they have very cheap electricity. So storage may not be so attractive in enterprising schemes like that, where a network operator like Octopus actually do a deal and buy the power from all the roofs that got solar panels on, and that's being done by Dorset Community Energy. And there's a deal being done so that the actual cost to the consumer is really cheap. Just thought I'd point that out.
Yeah, that's Octopus are quite innovative in that way of just looking at tariffs and the whole situation. That Simon was saying that they've done a deal with Tesla, where you can buy import for 8 pence a unit, export for 8 pence a unit, and okay, you've got to have a Tesla Powerwall as part of that service. But yeah, that's interesting. The Dorset one, I'll have to look into that.
Thank you. Are there any other questions? It's gone awfully quiet now. So I think in that case, I'd like to thank Simon and Richard very much for their contributions today from Solarsense. And thank you all, the rest of you, for turning up. I think it's been a very useful meeting. Thank you very much indeed. So maybe